Okay, so let's have a look at, now we're going to have a look at the second graph. It's called a truncus graph. Now, if you have a look at the format of it, it looks very similar to a hyperbola. It's 1 over x kind of graph, except this time it's 1 over x squared. So if you think about what x squared does, x squared means that whatever value we put in, we're always going to get a positive answer. So we're going to have the same sort of basic shape, the same principal shape. That is, I can't have x equal to 0. So I'm still going to have an asymptote here because my x value can't be 0. So that's the equation of my asymptote. And same sort of thing here in terms of, if you like, as x gets really big, I get 1 over a really big number, which means y gets close to 0. And if you like, as x gets really small, if x gets really close to 0, like a half, a third, a tenth, 1/100th, like 1 over 10 squared is 1 over 100. 1 over 1 over 1 over 100 will give me 100. So again, we're going to have our horizontal and vertical asymptotes very similar to our one on X graph. So that part is the same. What's different is 1 over x squared, but think about it. So 1 over 1 squared is 1, 1 over 2 squared is a quarter, 1 over 3 squared is a ninth. So it's got the same sort of shape here as my hyperbola. What's different, 1 over a negative number squared is also positive. So my truncus graph, there's my basic shape there. Okay, so you'll see there, x approaches infinity, y approaches 0. So we get close to the axes, but that's my basic shape. That's the graph you have to commit to memory. And look at a few key things here. I've got x minus 1 all squared on the bottom. So I know x minus 1 cannot be 0 because that would give me something undefined. So x equal to 1, well, that's going to be my vertical asymptote. So that's one asymptote. And since there's no plus or minus anything here, my horizontal asymptote's not going to change. So x equal to 1 and y equal to 0 are my two asymptotes. So we'll take that as 1. So there's x equal to 1. Label the asymptote. Y is equal to 0. Nothing else has changed. So we know that my graph is going to appear up here. It's positive. So clearly I need to try and find a y-intercept. So if I find a y-intercept, I always put x equal to 0. So y will equal 1 over 0 minus 1 all squared, which is just 1 over 1. So I get the point 0, 1. So we'll put that there. So I can just sketch the graph. So there's my truncus there. So the key point being really that x minus 1 in there, everything shifted to the right, not unlike a parabola does. Okay, let's look at B. So similar, let's think about asymptotes. Asymptotes occur when x is equal to 0, which is the denominator. The whole thing's been shifted up 2 units. So that means my horizontal asymptote is at y equal to 2. So vertical asymptote doesn't change. X equal to 0. Y equal to 2 for my horizontal. So let's make that 1 and that 2. So with the truncus and the hyperbola, put your asymptotes in first. I think that's the easiest way. All right, so again, it's a positive truncus, so we're up here somewhere in these two sections. So clearly on this side, we don't touch the asymptotes, so my graph looks a bit like that. Nor here, I don't touch the asymptotes, which means this one here, there is no x-intercepts. So let's show why there's none. So if I wanted to find an x-intercept or a y-intercept for that matter, we'll go y-intercept. Well, this time the x is equal to 0, so that's silly. So we'll go x-intercept would mean y would be equal to 0. So if I do that, 0 equals 1 over x squared plus 2. Let's take the negative 2 across. 1 over x squared. So you can see straight away, 1 over x squared, that has to be positive. it can't be a negative number, so there's no solution there. So there's another little, I guess, reinforcement that our graph has no x-intercepts or y-intercepts for that matter. But again, I guess the key point is the whole graph, it's a basic shape, but our graph here has been shifted up 2 units, which is what's happened here. So let's just do our third example here. So we've got both translations here. That's what we call when our graph shifts as translation. So let's go to our asymptotes. Again, I need, so for a, what is that going to be, a vertical asymptote, I need x minus 2 cannot be equal to 0, so x is equal to 2. So the whole graph shifted across 2 units, the whole graph up 2 units. Horizontal asymptote, the whole graph shifted up 3 units, so we've got y equal to 3. So let's put those in. So let's go 1, 2, 3, 4. We'll just get a scale that works for us. Vertical asymptote, put it in. And I reckon once you put the asymptotes in, so if that's 2 there, 3 is probably about here somewhere. So it's going to be a bit tight. Let's get a different colour. So we can see there's no horizontal, no vertical asymptotes. So there's one there, one there. We're going to have an intercept here somewhere. So how do we find that point? We put x equal to 0. So the y-intercept, let's put x equal to 0. So I get y equals, what's that, 1 over 0 minus 2 squared plus 3, which is 1/4 plus 3. So it's 3 and a little bit. So there's 3. The asymptote's a little bit up. So 3 1/4. So let's write that as 0, 12, 13 on 4. Something like that. Okay. So once you get that key basic shape, so if you see a truncus graph, first thing I would be doing is I'd just be going over here on your workbook, truncus graph, that means that. Just do that. Do that on your page and then work out your bits and pieces so you know exactly where it is. If you get a hyperbola, well, that means I know it looks a little bit like that. And then work out the bits and pieces for it, okay? Really practice a few of these questions. Get these done. I reckon, again, let's get the first few done and then come into class tomorrow and we'll get stuck into the others.